Welcome to Data Skeptic Machine Intelligence, our podcast series exploring contemporary topics in artificial general intelligence and large language models. A quick note about some background noise on my recording. As longtime listeners know, Linda and I have our pet parrot Yoshi. And what you probably don't know is we've also taken to doing bird boarding. We're currently boarding a cockatoo that seems to have had a rather rough life. He screams a lot, like a lot. I didn't think he was going to get picked up on my mic, but it does a bit. I've tried to hide it, but just given the nature of the screaming, you might hear at a couple of points. You don't need to notify the FBI. No one's tied up in the basement. I don't even have a basement. I'm a Californian. That's just Zeus looking for attention. So that's something that's going on with me. This is what's going on with the podcast. Today on the show, we delve into a very important topic. What are some of the illicit uses of LLMs? If I were to put on my villain cap, how might I deploy this technology? A good one is phishing emails, of course. We've all gotten them. Used to be some scam artist had to write those emails, even if they sounded like a machine wrote them. Well, now the machine actually can write one, maybe even a convincing one. And that's not the only potential illicit use. We get into that one and several others, as well as possible preventative measures. That's today, LLMs for evil.
My name is Maximilian Mozes and my affiliation is University College London. I am just finishing my PhD at UCL in natural language processing, working on the intersection of adversarial machine learning and NLP.
Well, you picked a very interesting time to get into NLP. What's it been like studying these past few years?
It has been very interesting, especially because of the fast pace of the field. There's a lot of sort of transformative news and discoveries happening in this field at the moment, which means you have to adapt quite quickly. This is something which was as interesting as it was challenging during the PhD, just because things move very fast and new developments and new progress is made very quickly.
And do you have a sense of, I guess, where we are on this adoption curve? Certainly something's going on in NLP. Are we at just the foot of the mountain or are we up the summit somewhere?
That is a very difficult question. Very hard to answer because the top of the summit is something I don't really know how it looks like, right? So I can't really say where on this scale we actually are. We could be pretty much anywhere on that scale because I don't know how far it actually reaches.
Well, we've seen large language models, even if there were no new academic advancements in some way, it seems like there's plenty of work for humans to do deploying these things in different areas. Lots of those for good. I'd like to see like situations where there are smart tutors and things like that. But I know humans as well, we're going to deploy it for bad. What are some of the threats that are out there?
Yeah, some of the threats that we also discuss in the paper focus on the generative capabilities of those large language models and how this can be misused in order to generate content that can be used by individuals with malicious intent. Examples of this that we mention are the generation of phishing emails, for example. Spam can be used with the aid of large language models. Spam emails can be generated automatically, for example. Another one is the generation of malware. This is something that has been shown and demonstrated that large language models can be used to generate code, which then turns into malware that can be used by individuals in a malicious way as well. A third topic that we mentioned in the paper is misinformation. So this would be the fabrication of information using large language models.
When it comes to like phishing emails and things like that, that's nothing new. Do large language models make it easier to scale? Like we're going to get more of these, or are they going to be more insidious in some way?
Yeah, I think they are definitely helping with scaling these things up and ensuring that phishing emails can be generated much more quickly on a much wider scale. We mentioned a paper in our paper that looks at personalizing phishing emails using large language models as well. What the author does in this paper is combining Wikipedia biographies of known individuals, and then generating phishing emails that are tailored to details that can be found in those biographies. And this is something which can be scaled up, of course, much more quickly as compared when humans have to write these phishing emails themselves.
Well, that sounds dangerous in the sense that I know lots of people have Wikipedia pages and they don't all have like dedicated security teams looking out for their cybersecurity. But there's someone of stature. I know I'm not an important person enough, I guess, to have my own Wikipedia page just yet. So is the average person under a threat?
I guess so, yeah. It really depends on sort of the subject and what is actually being discussed in a phishing email. But I feel like Phishing emails are a real threat, of course. They're very effective. They're very dangerous. And using large language models to generate these things potentially more convincingly as compared to when humans do it or as it has been done before, this is something which can turn into a real threat, in my opinion.
Well, with the threat of personalization out there, I can also look to the other side and say maybe the large language model could be the hero here. You could use it like an email filter and ask it for every new email, does this look like a phishing scam? Yes or no? And I would expect an LLM to have some success in that. I don't know how good of a success, but is this a cat and mouse game that we can win in that way?
To an extent, yeah, I think this relates a little bit to this field of detecting AI and LLM generated content, right? In order to make sure sort of whether somebody can identify whether something has been LLM generated or not.
And then where does AI safety fit in? It's a big topic, and we've covered a few times on previous episodes, but how do you think of applying that to the field?
Yeah, I mean, AI safety in this context, as far as I understand, would refer to ensuring that large language models don't respond to queries that are potentially harmful, that potentially make them generate things that can be misused by individuals. For example, the generation of hateful and offensive content, but also the generation of malware. AI safety, I think, yes, is a very sort of important topic here in this context because it helps preventing these kinds of things from happening.
Where are there opportunities for that safety to take place? Should that happen, in the model training phase, or maybe something in the reinforcement learning phase, or perhaps it's a company that's going to use a base model and deploy it? It should be on them to protect their users or something like that. Where are the opportunities?
Yeah, there are different ways of approaching this problem. So as you say, one could, for example, build something like an LLM content filter that would generate an LLM generation after it has been generated. Another approach would be to directly tune an LLM in order to be more responsive to things that are potentially harmful. There's sort of a lot of work going on between these different ways of approaching this task. Which of those turns out to be more effective or more efficient is something that's quite difficult to answer, I think. One of the advantages that we have discussed between these two, well, or for LLM content generation specifically, is that it can be used without adapting the actual model. When you tune a model in order to be safer, this is something which is arguably good, but it also means that you interfere with the model. And this is something with which you don't have if you have a sort of a post-processing step that analyzes an LLM generated piece of content and identifies whether it can be released or not.
Well, the development of large language models used for phishing attacks is, I don't want to say it's obvious, but I'm not surprised, right? It seems like, hey, write me a scammy email. And anyone who's used one of these large language models knows you'll get some level of success with that. But when it comes to something like generating malware, it's not obvious to me. I use these models to generate code, but they're not perfect. They're not ready to replace me. I don't know that I've been 10x'd, but I've probably been 2x'd. Is it the right time? Is it viable that someone could write malicious software and leverage these tools to help?
I think it is important to look at these problems as early as possible in order to be able to identify them before they potentially become too problematic, right? If we sort of think about these things early on, I think this is something which is quite important because it helps us prevent these things from happening in the first place. Looking at sort of these generative capabilities and how they can be misused is, in my opinion, something that is quite important, especially as we see that large language models are becoming more and more popular and find more and more sort of quickly find their ways into consumer products.
Well, with malware, I would like to think that there are security professionals out there on the good team, so to speak, maybe feeding it a snippet of code and saying, do you see any possible opportunities to exploit this code? And could you recommend a fix to make this a more secure software? And I wouldn't want to stop a professional from doing that, but a tool that can help that person can also help a person find and exploit functionality. So I don't know that there's a bias one way or the other in the model, but I don't. Do you have any thoughts when framed in that way?
As you mentioned it before, be it in a different context, but there's always this cat and mouse game between how these technologies can be used and to what extent either sort of side can be using these technologies. It's something which is quite difficult because comparing this to traditional computer security, I think this is a concept, a phenomenon that has arisen in the past as well.
Well, in terms of preventative measures, then, I think it would be wrong to say let's ban LLMs or let's say it's illegal to use them for cybersecurity because it can be for good or for bad. As these tools are developed, we want to release them responsibly. What are some of the preventative measures that could be taken?
Preventative measures, so these are things that we discussed earlier, building models that respond accordingly to queries that potentially make them generate harmful content, or content that can be misused or is intended for malicious purposes. As we have discussed, we have multiple ways of approaching this, either by directly adapting a model, changing its behavior through approaches such as reinforcement learning from human feedback, or fine-tuning a model specifically in order to safeguard against these potential misuses, or you use an additional content filter that processes an LLM output and decides whether it is something that should be released to the user or not.
What about something like red teaming? To what degree do you think a team should be investing in strategic initiatives like that?
Red teaming, in my opinion, helps in potentially identifying issues with models, and especially also with the safeguarding mechanisms that are already in place. So this would be sort of another approach of identifying failure cases of those models, or failure cases of the prevention measures that are employed in order to make those models safer. Red teaming, in the paper, we discuss red teaming from two different angles. We discuss sort of the more traditional way of red teaming, where you have human individuals red teaming a language model, and then we look at other more recent work that uses language models in order to red team other language models.
Well, if you were, I guess, tasked with setting up a red teaming operation, maybe it's something as broad as the Bing chatbot, where there are millions of queries per day, and I'm sure more than a few people trying to test the edges of it and get it to say ridiculous things. Do you have any thoughts on how you'd set that group up and what the key initiatives would be?
It really, in this case as well, depends on, I think, the specific task that you are looking into. This is such a, sort of such a broad problem. There's so many ways of how you can generate potentially harmful content using a language model, and covering all of these with a single effort is something that is close to impossible. So I feel like it really depends on, first of all, which task, which specific focus do you look at. Given that we have seen that large language models can be used in order to red team against other large language models, this is something which seems quite promising in my opinion, because it scales things up. Of course, it makes things much faster and potentially much cheaper as well, because you don't have to incorporate as much human workforce as you have to when you assemble a human red team.
I definitely agree that it's going to be task specific, that what it is to be safe or even what sorts of behaviors you want to prevent are going to be very different depending on the use case. Does that mean that every team working on these deployments is going to need to invent their own tools and find their own path?
To an extent, I guess this can be true. I think it really depends here as well. I don't think there's a single approach that can be helpful in order to protect large language models from individual misuses. I think this is and will remain something which is incredibly use case specific.
And what about the use case of reinforcement learning with human feedback? What is considered offensive? Let's say that could be our task. That's going to vary, a lot. What's offensive in like an elementary school community group is very different from like some sports fans group that talks about the game and trash talks the players. So the language model can learn a certain amount from whatever raw data is in its corpus, but we know there's this process of human review and using that to then weight and guide the answers. That's some proportion of what people work on today. Do you see that becoming a bigger part of this, or what will be the role of RLHF in the future?
Yeah, to address the first sort of point that you mentioned, labeling based on the definition of whether something constitutes offensive content or not is of course incredibly ambiguous. It's very blurry. It's a very difficult task, and agreement between individual annotators can potentially be low as well. So this is an open challenge, and to be fair, to me, it's also quite unclear how to deal with this problem specifically, because I feel like definitions, like fairly often when it comes to these kinds of tasks, and you'll find so many corner cases that the labeling in the first place becomes one of the most challenging problems that you're faced with. Given that, we see that RLHF tends to be a promising approach in order to increase the sort of the harmlessness of large language models, as has been seen in some of the papers that we mentioned in our overview work as well. So I do see that this is a promising approach, but as with many other things, we have a lot of open challenges that we still need to address.
Are there any you want to highlight? Maybe certain limitations in the process?
Yeah, one of the limitations, of course, is, I guess, the difficulty in labeling things, and how this sort of potentially affects the behavior that the large language model exhibits after it has been tuned using this approach. This doesn't specifically relate to RLHF only, but also to other approaches, fine-tuning large language models, right? Because if you have ambiguity in the labels, the extent to which this sort of impacts your large language model after it has been fine-tuned is something which doesn't seem to be known, is something which, yeah, I would see as an open challenge.
Well, it's relatively easy to spin up a large language model today, whether you use one of the API-based services or you use something like Hugging Face to run Lambda 2 locally. Person with you know not zero development skills, but pretty minimal development skills can spin this up and start using it. And because of the speed with which they can do that, I can easily see that the momentum gets caught up pretty quick in what you're doing, and you just kind of run with it. And maybe safety became a backseat or something that you didn't even know to be concerned about until things got rolling. For a person in that sort of position who is concerned with the role of whatever they're doing, and obviously it's going to be task dependent, but for someone who wants to take safety into consideration as they're moving through a project, what are some of the key places to start?
I guess awareness of potential limitations of those large language models before they're being deployed is something that is quite important in the first place. So our work also attempts to address practitioners of large language models that are not necessarily familiar with these limitations, and tries to provide an overview of things that can go wrong when using these large language models in practice. So being aware of these limitations is something that is quite important, ideally before you deploy the model, because then taking prevention measures and approaches to potentially prevent these things from happening is something that becomes a little easier.
Well, in a lot of machine learning problems, there's a lot of ways you can try and influence the model. So, data poisoning is a big one where maybe I would try and get some of my examples into the training data set to skew the outcome in the way I wanted it. If we're going to crawl the web and build large language models off of web traffic, it seems reasonable a person might want to kind of poison the internet and get some data out there, be it for misinformation or marketing purposes or whatever. Is this a credible threat that we're going to have to face in the future?
Yeah, this is something that is, I guess, to be seen in the future as well. I agree that to me it seems like this is something which might not necessarily be an imminent threat right now, but it's something that is technically possible, as has been shown in several works. And therefore, it is a potential threat which we should think about as early as possible in order to make sure that we can prevent this from happening as effectively as possible as well.
Well, I'm thinking again of the person trying to deploy these technologies. On one hand, it's very exciting. It seems like they can do a lot, maybe solve customer service issues and issue refunds and these sorts of things. But they also have the potential to do harm, even, not just accidentally. Maybe you can control it for something simple like a checkout flow. But if the customer starts saying, I want to know the credit card number of the last person you spoke with, or something along these lines, I've seen a lot of examples where you can manipulate the models into telling you something that they seem to be trained not to tell you. What is the threat of this sort of workaround jailbreaking approach?
Yeah, that is an incredibly good point. I think this sort of scenario relates to multiple technical issues that we see with large language models. So this is not only jailbreaking in itself, but also this concept, this idea of data memorization, right? If you fine tune a language model on, for example, customer conversations, and a user interacts with a fine-tuned model and makes it generate examples that the model has seen during training. And these instances seen during training could potentially contain private, sensitive information of other individuals, other customers. It can become a potential threat that users can exploit this in order to extract private information from other customers that this model has been trained on. So this sort of combines these two aspects of jailbreaking and data memorization. But jailbreaking, in my opinion, is only or is an approach that actively tries to circumvent a safeguarding mechanism that is in place for a large language model. And for data memorization, this is not necessarily something that is actually in place. So we have seen that large language models tend to memorize training data, and then once prompted, they can generate training data without any hesitance, I would say. Yeah, this is something which can become a problem, especially when you train large language models on sensitive and private information.
And what's the current scholarship on maybe approaches to avoid those sorts of things?
Yeah, the literature, as far as we have seen, is fairly scarce. So we have seen a paper that looks into using reinforcement learning in order to tune a language model and incentivize it to generate paraphrases of the training data rather than learning to predict the next word only of the training instances themselves. This is an approach that we have seen. And there was another approach that looks into using prompt tuning techniques on privatized data in order to incentivize a language model to not return private information. So privatized data means the model is tuned on data that has been privatized before the tuning actually happens.
And are these sort of like nice works and good efforts, or is there anything that they can give us a guarantee on these sorts of, privacy protecting services?
I don't think that the works we explored give guarantees. I think these are empirical approaches investigating whether these methods help or not.
Yeah, I think that's just the world we live in. I don't think you can make a guarantee, I guess,
Yeah,
is
yeah,
the
yeah.
salient point, maybe. Having explored the possible uses and misuses, what do you find to be the most credible threat to our society from large language models as it stands today?
That is also a very difficult question. I can mention two that we particularly focus on in our work. The first one is LLM personalization, which means you use large language models, or large language models become more personalized to an individual that is interacting with them, that is using them. We refer to existing work as well that looks at sort of an overview of potential threats of LLM personalization, which we also discuss in our work, and see this as an important problem to look at, a potential threat, because while it can of course be very helpful in order to supply individuals with content that is personalized to their interests and so on and so forth, it can also be misused. It can also lead to problems. The second one that we discuss in our work is the generation of misinformation, which we see as a potential problem for the future as well, because it becomes more and more difficult to distinguish between misinformation and credible information, whether it has been generated by a large language model or not. So we've been made aware of an approach called countercloud, which shows that you can completely automate the generation of entire news websites that seem to provide credible news information, which actually turns out to be misinformation. Yeah, so I think making the distinction between whether something is AI generated or not, especially in the context of news and yeah, potentially misinformation, is something that can become incredibly difficult.
Well, fake news is not a new idea. It's one that has been prominent, at least in American politics, in recent years. There are, lots of claims that Russian interference happened in the last U.S. election. The degree to which it influenced it, I don't know how we exactly measure that, but I think there was some attempt, at least, we have to say. There could be another attempt in the future, be it from Russia or some other nation state, and now they're equipped with these much more powerful tools. How much more threatening is fake information in the LLM era versus pre LLMs?
Well, I think it just speeds up the process, right? It speeds up the process because there's less involvement of sort of human workforce here as well. Things can be automated more efficiently. And at the same time, the quality of the generations and therefore the sort of pieces of misinformation that large language models generate increases as well, which means it makes it more difficult to detect and at the same time more convincing for readers.
Well, one thing we could maybe do is try and have some sort of watermarking process where, I don't know, I could get a browser plugin that says this page was probably generated by an LLM or something like this. Of course, I'd have to install that and it would have to exist first. But is that even feasible? Are there good algorithmic or analytical ways where we can determine human versus LLM generated text?
Well, there are many efforts currently looking at these approaches. And then, as you said, watermarking is one of them. But as with other approaches that we have talked about as well, there is this cat and mouse game here too, right? So there's approaches that build methods in order to detect whether something is AI generated or not, and then there can be other approaches that try to sort of um, like mitigate the effectiveness of that such approaches and ensure that the detection capabilities of models can be defeated as well.
Well, we've seen a pretty steady progress of different LLMs coming out. If we go all the way back to BERT, was a big impactful one, up to now GPT-4 or Lambda 2, and these are only going to get bigger. Does that mean that the threat is going to also get bigger?
Potentially, yeah. I guess that is something which is also to be seen, but I can imagine that this is true because the generative capabilities of those models increase, which means that the sort of the space with which these models can be, or in which these models can be used and can also be misused, cannot shrink, right? It can potentially grow, but it can't get smaller than that because the capabilities of those models increase. So there's a potential for those models to be used in new contexts that we haven't thought about yet because of the fact that they are growing.
Well, the future is notoriously difficult to predict, but I'm wondering if you might humor us and prognosticate a little bit. What do you think we're going to see in the near future? Like, are new professions and titles going to emerge for this specialty, or how will industry or government interact with it? What do things look like in 5 years, maybe?
Yeah, I can definitely see that there will be an increasing focus on the safety of large language models specifically as we see them grow more and more into consumer products, into the daily lives of individuals. Should we see potential threats arising from the deployment of large language models in these contexts, I think that there will also be an increase in teams working on the safety for specific scenarios, specific settings that these language models are being used in.
Well, we've talked about mostly bummers today. I don't want to be, catfished or anything like that myself. Do you have a view on maybe anything you're most optimistic and hopeful about? Where are LLMs most exciting for you?
Well, I think they're exciting in very many different ways because they can aid human productivity in so many different ways as well. They can, yeah, act as a search engine, which I think is incredibly interesting. They can answer any questions and queries that you have. From educational viewpoint, I think large language models are incredibly useful. If we can sort of ensure that they generate accurate information, I think it is something that is incredibly powerful because, yeah, they can be used very quickly, very efficiently.
Well, Max, what's next for you in your work?
I am just finishing my PhD and yeah, working a little bit on sort of my previous or my primary research interests in the PhD were focusing on adversarial machine learning in the context of natural language processing. And with the development and sort of the growing popularity of large language models in our field, my interests have shifted a little bit towards the safety and security aspects of large language models.
And then, is there anywhere listeners can follow you online?
Yeah, I'm on Twitter or X with the username Maximilian Mozes.
We'll have links in the show notes for listeners to follow up. Max, thank you so much for taking the time to come on and share your work.
Yeah, thank you very much, Kyle. It was very interesting.